Well, hello, everybody. This is Mrs. Ellsworth. So, I bet you've been thinking about way back last year when we were studying chemistry about, yeah, I know you got my joke about last year, huh? Anyway, we talked about whether something was polar or nonpolar. We did a lab where we actually would see like dissolves like. So if our polar water dissolved something that was a polar molecule, and that it had this uneven distribution of electrons. And so what you're going to be doing today is you're going to be doing a lab. That's a PhET lab simulation showing polar molecules. But then we're also going to be looking at the math to determine whether something is polar or nonpolar or ionic. And so that's what our big excitement is for the day. So we're going to be comparing bonds between two different types of atoms. And okay, so bond comparison. So let's talk about what covalent bonds are and ionic bonds. Covalent bonds are atoms that share electrons. That's pretty cool. So that's what our Lewis dot structures we've been showing. We've been showing how they hang on to each other's electrons so that they have 8 electrons around each one, except hydrogen, of course, only has 2. But anyways, these are bonds between nonmetals and nonmetals. And we call these ones molecules. So when they share bonds, have covalent bonds, I should say. When they share electrons, they are molecules. When they are ionic, that's very different. This is where atoms are stolen from one atom. They steal the electron from one atom to the other. And so now one has become positive, the other one has become negative. So the metals are always positive, the nonmetals are negative. Those charges, those valence and oxidation states that we wrote above our different families on the periodic table. Anyway, when there's a positive and a negative coming together like that, and that it becomes an ionic compound. Okay, so let me show some examples of that. So here is carbon is a nonmetal, and hydrogens, 4 hydrogens are hanging on to it. So this is kind of a different way of seeing a Lewis dot structure about this. And this is a great way to still demonstrate it anyway. So like let's say that carbons are all the blue dots. It's got the 4 electrons in its outermost shell. And so it's going to bond with hydrogen that's got 1 electron in its outermost shell. And they're sharing the electrons. And so that kind of glues them together. I don't know if that's a very good way to say it, but they're hanging on to both of these because electrons have the opposite spins and they're attracted to each other. So that attraction creates this bond between the non-metal elements. Okay, now over here, oxygen had, I don't know if you remember, but it was missing 2 electrons, and magnesium should have 2 extra electrons in another outer shell here. And so what happens is that those 2 electrons just zip over here because it stole them. The attraction thing, from a highly electronegative atom compared to a not so electronegative atom, it actually steals them. Now they're attracted to each other's nucleuses, and so with these charges, and so the electrons over here attract to nuclei in that one, and vice versa, and so they become just attracted. That attraction there is stronger than a covalent bond. That's why they have really high boiling points and melting points and all that. But anyway, this is an ionic bond between metals and nonmetals. This here is just between nonmetals. Okay, so oh, I kind of gave this away. Which one of these is a Lewis dot structure? And oopsie, I missed it. It would be definitely the covalent bonds. Okay, so when we're thinking about this, how can we figure out what the bond type is? Well, I'm going to ask you to use this chart right here. There are also electronegativities in the back of your periodic table. Okay, but for the exercises you're going to do today, I'm going to ask you to use this chart right here because they're nice round numbers, and we're going to go with it and go with it quickly. Okay, so notice that this is the electronegativity, and that fluorine has got the highest electronegativity. None of the noble gases do, and that over here, I think that we're missing a whole period here, but it was over here on this periodic table. It shows cesium right here being 0.7, that these darker green ones are lower. These are a little bit higher. The white ones are a little bit higher again. Oh gosh, these transition metals, they just don't always follow everything perfectly, which we've learned that several times. Okay, and then we get to higher, and then these blue ones are even higher. Hydrogen, of course, just does not fit in everything, does it? But anyways, this 2.1, and then carbon, sulfur, they're getting a little bit higher, and then here now they're getting extremely high for electronegativity. So just like you learned from the periodic trends unit, you gain in electronegativity as you go to the right, and also as you go up in the families. Okay. So now we can take this information, these exact electronegativities, and we can figure out what type of bonds that things have. Okay, so moving on. Hello. There we go. Okay, the difference in electronegativities between two different atoms. If it is greater than 2 and equals 2, then it's going to have an ionic bond. Okay, if it is between 0.4 and 2 and it does not include these two numbers, okay, then it's going to be a polar covalent. Now, both of these two are polar. Take note of that. They're both polar, but this one is just not as strong of an attraction as an ionic bond. Remember I said that ionic bonds are so strong with that attraction between the positive and negative that they are just really strong in their bonding for electronegativity differences. Okay, and that makes them polar. Okay, they have electron density on one side and not on the other. Okay, and then we got one more, which is nonpolar covalent. So if it is equal to 0.4 or less, then that means it is going to be a nonpolar covalent one. This is the only one that is nonpolar. The other two are polar. Yeah, I repeat myself once in a while. Anyways, let's go ahead and do an example. We know that salt, table salt, that it dissolves in water, so we know that it's polar. Okay, and we did that in our lab. And so let's go ahead and see what happens here when we look at the two different values for it. So we're going to look at sodium and we're going to look at chlorine. Sodium on that table that we just had for the previous slide is 0.8 and chlorine is 3. So we'll take the difference of those two and we get 2.2. So what does that mean? It's ionic. Okay, so it's an ionic bond. Okay. And that's actually all that we got for this part. Okay, so that's all you got for right now. So this will hand you a small worksheet so you can figure out which ones are right here, which ones are ionic, polar covalent, and nonpolar covalent. And have fun with that.